Assalamualaikum. My name is Muhammad Aidil bin Zuraidi. Today, I would like to present about my title, which is Bending Effect of Different 5G Wearable Antenna for Health Monitoring Application. Okay. For the introduction, the fifth generation deploying worldwide in 2019 and becoming fastest wearable wireless technology ever created. Okay, the fifth generation 5G technology is revolutionary technology that will not only meet the ever increasing data rate demand for mobile terminal, but also allow for integration with numerous services. Wearable technology is common device used in monitoring such as human or animal wearable device are commonly being utilized to assess various bodily signals such as electrocardiography, pulse oximeter, blood pressure, and body temperature. The bending of flexible antenna varies with frequency and becomes critical at higher frequency due to the antenna's tiny size, resistant mismatch, and restricted bandwidth. The antenna is expected to be fitted into a suit in a realistic on-body application where it will be susceptible to bending. Okay, there are several problems that I have this title, which is the body part. Okay, the antenna will place in the human body part, so it will radiate into the human body. To avoid that happen, the the bending effect was introduced by using 5G lower band frequency. Okay, to overcome the problem, two objectives was created, which are the first one is to design and simulate 5G wearable antenna for health monitoring application, and the second one is to investigate the bending effect of 5G wearable antenna using different wearable substrate. Okay, for this project, it's use non-chemical design so that the material is easy to find, which is felt, cotton, and jeans. These three different material or substrate is using the different dielectric permittivity, namely 2.1, 1.3, and 1.68 respectively. The dimension for the cotton felt and jeans is 27.5 mm times 37 mm. For the felt, 33.5 mm times 45 mm, and the last one is for the jeans, 30.7 mm times 39.44 mm. The antenna then bend under several radius and performance such as S11 return loss, VSWR, and gain were investigated. Okay, next we continue with the result. Okay, for the result, I have put the graph for X parameter with three different material that I have been used, which is cotton, jeans, and felt. Okay, all of this material for each of the graph, I have bending it with three different radius, which is 25, 45, and 75 mm, which is all of this radius is represent the bone, skin, and fat of human body. Okay, we also can see that the example of the antenna that bending on human body and the design that had been made. Okay, for the table parameter material, we can see that for the table parameter material, we can see that the parameter that measure is frequency, return loss, S parameter, VSWR, and gain. Okay, for the three different material we have been choose, the best one is jeans because the frequency that have been measured is 3.5, exactly the value of the lower band frequency of the 5G, which is 3.5 or so. And then the return loss for the S parameter is negative 29.93. The value is sharp. The curve is sharp into the bottom of the graph. So it's compared to the cotton and felt, jeans is becoming the best return loss of X parameter. And then the jeans is become the best material that has been used for the bending effect. Okay, for the conclusion, this bending of the antenna process is due to replace the human body curve by converting it to an angle. This is done in order to avoid the radiation against the human body and predict the performance of the antenna in wearable device. Hence, it will affect the health and safety of the human body. The best wearable antenna is changed after the result was taken based on the frequency, return loss, BSWR, and gain. Okay, there are several reference that I have been used. There are two several reference, which is from the L Song and Y Rahmat Sami, which is the systematic investigating of rectangular patch antenna bending effect for wearable application, and the second one from the SR Manasseh Gonzalez, RT Rodriguez Marquez, which is the microstrip antenna designer for 3.1 until 4.2 GHz frequency band applied for 5G mobile device. That's all from me. Thank you.